The title of this presentation today, Fog Computing on the Plant Floor. It is mostly on the plant floor. It is about fog computing, clearly. But it may be also interesting for some of you who are not only related or interested in plant floor, but also in other kind of environment, industrial or not. My name is Ivan Zorati. I'm the Chief Product Officer at Dynamic System. A very, very brief introduction about Dynamic and what we do. Dynamic is a startup company based in Menlo Park, so we are here locally in the Bay Area. I'm originally Italian, living in England. Dynamic stands from, well, it comes from the Greek, dianomi, which means distribution or distributed. And actually, we refer to the distribution of resources to achieve one simple goal, simple to say, difficult to achieve, clearly, simplify IoT data. Simplification, which means we really want to provide solutions or, let's say, a software that can help everybody in making IoT and IIoT solutions and product faster, quicker, less expensive, and more reliable. So in a way, we want to help, of course, in this quite aggressive and ambitious goal. We've seen lots of keywords and themes today, right? And also in these days at the OSIsoft, at PyWorld. I like really, there is actually an empty space there, and I like to add this, fog computing. Let's see, first question for you. Who knows something about fog computing? You've heard the term, or you already know some? Okay, one person, two, okay, not many. And of course, this is the right place, clearly. If you don't know anything about that, or if you know a little bit, hopefully to improve it, and why it may be important for you. And I think that the most important slide for this presentation is this one here. This is actually from Cisco, as you can see. So 75% of IoT projects are failing. Do you believe it or not? Well, that's up to you. This is a survey from Cisco. Now, there is a URL down here. You will see, of course, the slides. They will be downloadable for you. But I really invite you to go and check this because it's quite interesting what is the content. I'm not going to talk about this content. I'm just saying this is one of the points that I'm trying to make when I say simplify IoT data and, in general, make IoT simpler for everybody. So why is that? Why 75% of these projects are failing? We are in a fragmented world. That is what we believe, and not just us. All the surveys, not just the providers, but also the end users are telling us. Reaching the fourth revolution, industrial revolution, especially in industrial IoT. IoT, if you may think it's something pretty new, where we moved from connecting people to connecting things or connecting everything. Here we are talking about something that, of course, it evolved for general and business interests. But where we are today is a world that is all connected or going to be connected, but extremely fragmented. And this fragmentation is the real problem. The fact that you have thousands of devices, sensors, applications that run everywhere, and they must be integrated together. And this integration goes through network elements and components and connectivity that rarely work well together. There are standards that are not standard, or there are too many standards. The result is incredible complexity. So what we define as a brownfield is our IIoT challenge. I already mentioned fragmentation, and again, I want to put it on top up there with some of the examples in terms of different hardware, different protocols, etc. But the complexity goes down to security, one of probably the top three challenges in IoT and IIoT. And the reliability of systems, of data that is available, the integrity of data, the integrity and reliability of the network. the whole life cycle management for your IIoT environment in terms of provisioning, in terms of configurations and upgrades or updates that we may have. So it's really, well, I think it's quite clear, and we shouldn't spend too much really time on this because there are lots of other things. But it's just to give you an idea of what we are facing and why this discussion on fog computing is so important. Now, from the brown field, something that is now based on trillions of dollars of investment, to the green field, you may think, okay, now it's getting better. This is from Matter.com, okay, and First Mark Capital. They created the IoT landscape, and it's pretty new. It's January 2018. They counted something like 971 companies involved in IIoT. We're not talking about IoT, but industrial IoT, where there are, of course, several verticals. AI is at the top of the pyramid here, where we define what to do and how to use all these technologies. There is, of course, a request, a demand for increased connectivity, and there is another point, more edge computing. When we talk about more edge computing, we refer to the fact that there are sensors and things and devices at the very edge, at the very bottom of our pyramid that I'm going to show you in a moment. And there is more and more need to have resources down there to execute, control, configure, but also to gather data and use and consume this data at that level. But that's only one aspect. Now, if we go from the brown field where we have fragmentation and complexity to a green field where we have so many companies and so many standards that are related. Actually, we're not mentioning them here, but there are. Have we achieved something, or have we made this even more complicated and complex to connect and integrate? I believe the problem is that if we just start from scratch with the green field in this way, we haven't achieved anything. It will not really start up as we expect. And that is one of the reasons, if you read the Cisco survey, why we have 3/4 of the IoT projects failing. So, we are at PyWorld. Let's have a look at these aspects based on what we have today. So, our Pi system. In the brown field, we have our systems down here, and we connect at the edge through the Pi connectors and the Pi interfaces. In some way, we are able to take what we have down here, collect the data into the Pi systems, whether they are plant operators or they are up to the enterprise, maybe at a higher level. Now, the problem is the green field over there it looks a little bit like this. Now, my friend, a colleague, Bill, you may have seen maybe his presentation Monday. He had probably a nicer way to present all this animated, but the final result is quite disorganized and messy, meaning that you have the green field and everybody here is trying to propose an IoT solution that works in parallel with what you already have. The end user and the customer at the center of this is in some way connected with what he or she has on this side and all these other new arrows on the other side. And that is not a unified view, of course. It's something too complicated, and it doesn't really work well. It may work well in some cases, but definitely a unified view, as Pat Kennedy explained Monday in his keynote, is what the Pi customers are looking for. So having said that, having defined what are the issues and the challenges here, let me introduce you to a concept that I think it is new, but I think it's quite obvious to grasp as soon as we show you like a few examples. The concept of fog computing. We're all familiar with cloud computing, clearly. Everybody is using in a way or another, as a consumer or as a business user, cloud systems. So what are fog systems? There are lots of definitions. I leave the definition up there if you like to read it, but just in reading short terms, we are talking about taking what we have defined in the cloud, all the technologies that are defined in the cloud, at least from an architectural point of view, down to middle layers or even to the bottom where we have the edge, where we have the devices, the sensors, actuators, etc. So we apply systems that can be distributed, they can be virtualized in some cases, that they are all connected. That is what you usually have in a cloud environment. In a middle layer where we have systems that aggregate information all together, even down to the edge. And that is the concept of the fog computing. Fog meaning something that sits between the very, very bottom and the sky on top, the cloud on top. So that's the idea. And if it's still something so vague as a term, let's go and see some of the use cases where fog computing really makes sense and what it is really in practice. Here's an example on smart roads. Smart roads where we have a connectivity of systems that are maybe the traffic lights in these roads that clearly are organized, and they rely on the fact that there are sensors that can see the traffic. They can actually count the cars that are queuing or they are moving from one road to another. But it's not just what they have as a sensor on top of the traffic light, but what is really, really interesting is the fact that maybe the previous traffic light can interact with the next one, or even the next one, or the entrance maybe in a town or a city where we say, okay, like we have this junction, and from here there is actually a flow. Today there is a flow of cars of this amount per minute or per hour, and so we are expecting at this other traffic light, a certain amount of cars moving and so on. Now, if you expand this to more integrated services, you can even consider what can be done in vehicle. So you may have in-vehicle sensors, and they can be bidirectional. So, of course, you are familiar with Google Maps or and other tools. They can basically interact with these systems, always preserving your privacy, but just defining the number of vehicles that are currently moving in a certain area. And that is, in some way, the concept of fog computing, which is not just the connection, but is the consumption of the data and the use of several resources wherever they are needed. Not going always on top, but sending then this information down to the bottom and then use them there. Smart buildings, it's a similar concept. Here it's probably even easier to grasp because you have even physically a structure with multiple layers. Now, the layers are not really on the floor side, but on the fact that you may have sensors that identify, for example, motions of people moving or people connecting to the internet with Wi-Fi or other devices. And then the fact that these systems can concentrate then data into local servers, and these local servers then can help in defining, of course, the maintenance and the temperature for the various rooms. They can help with fire detections and security intrusions, etc. So it's in some way a smart building may become something like a small data center where you can distribute your services on multiple layers. Now, one important point here is that in order to provide a fog computing environment in a building like this, what you need to have is an infrastructure of hardware and software that is available and can use this fog computing at many, many levels. So I'm talking about smart sensors, and not only sensors that must always be connected to some other systems, or I'm talking about computers, literally full operating environments like Windows or Linux based, that I have a small factor and low power consumptions, and they can execute applications that can be uploaded and then executed whenever needed, and they can also change. That is one of the important aspects, the fact that you don't have something embedded that you will never touch, but you can change over time whenever it's needed. And similarly, if you combine all these things together, the concept of fog computing is very much related to smart cities, where you have even multiple cities where they can interact and have communication among buildings, among the smart buildings, or hospitals, or highways. We were talking about the smart roads before, etc. Now, one of the most important players in fog computing is the Open Fog Consortium. So all these wonderful scenarios of interconnectivity of everything requires, as I mentioned before, standardization. And when you have too many standards, you don't have any standard. And the whole idea of the fragmentation that I was mentioning before, okay, it's something that is really addressed by the Open Fog Consortium. The Open Fog Consortium has been defined under the IEEE umbrella about 3 years ago, but it's been active in the last, let's say very active in the last 18 months. Dynamic and OSIsoft are part, as you can see somewhere here in the list of brands that are available, part of the consortium. You see on top the main founders and contributing members. You can pretty much see everybody in the IoT and IIoT world participating. Let's just it gives you an idea of how important is fog computing nowadays. Why is that important? Because if you refer to a reference architecture on fog computing, where we define what is needed to set this fog environment with resources that can act at any layer, at this point, all the names that you see here can really work together. And so if you are part of these organizations, as I am, for example, I'm very happy to say, well, I can not only work with OSIsoft, but I can work with NEC, with NEC, or with Microsoft, or Intel, Cisco, etc. If you are an end user, you are really happy to say, well, I have, of course, many of these vendors, and I can use them in a fog environment. So the reference architecture here is based on 8 pillars. And some of the solutions provided by the brands that you've seen before may relate to only 1 or 2 of these pillars. Other solutions may relate to all of them. They are all, let's say, probably, I would say, equally important. It really depends on the resources you need, on the infrastructure you need to build. Definitely, security is here, number 1, at this level, because it is an essential element. And here we are not talking about security just in terms of authentication inside your network, so trust on one side, but also privacy, for example, or attestation, identifying that, speaking of data, identifying that the data that you are now collecting and you're maybe analyzing comes from a reliable resource. We know which resource. We know where it is now, because in fog computing, data moves. We have another important concept. Let's say in the old days, we were usually talking of data at rest. Data is somewhere stored. In fog computing, the combination of data at rest and data in motion is the real complexity. And we need to have systems that can connect and that they can handle this duality, the motion and the rest. You can't have one or the other. You must have both, and you must control both. I will give you an example in a few minutes. Scalability, well, it's quite obvious. We were talking about cloud computing. It's all about elasticity, more even than scalability. You scale up and down, you scale horizontally. Well, the system must be scalable. And let's bring this scalability down to the edge. You need to control what's going on in your pipeline. Okay, you check the pipeline. You need thousands of sensors that must be deployed tomorrow. And you must be able to have these sensors immediately collecting data to check if the pipeline, what is the health situation with your pipeline, as an example. So orchestration comes clearly with scalability and the control of this from an overall system. Now, I'm not going through, of course, all of them. Otherwise, I would probably stay, and I'll keep you here for another couple of hours. But you see, the idea of being open is another important point, which is really what we really believe in. The fact that there must be open systems. We, as a company, develop open source software. We believe that all the problems of fragmentation that you see in the brownfield and all these problems of so many verticals and so many brands and solutions that you see in the greenfield can be really successfully integrated and can work together only if there are open systems. And in our case, we can provide open source software that can work for everybody. But I'm going to be a little bit more specific in a few minutes again. And then you see the idea of, for example, let's pick up another one which is quite important, the hierarchy that I mentioned. The fact that you must execute or use or consume your data at the right level. It doesn't make sense, of course, if you are on your car and you need to analyze what's the status, or in a truck, and you need to analyze the status of your vehicle to send data up to the cloud, and then the cloud system will tell you, oh, by the way, your vehicle is fine, or no, you have a problem. You must have this analysis executed at the edge, of course, in your vehicle. That's just an example, but there are maybe thousands of others, of course, on this type. Based on those 8 pillars, the OpenFog reference architecture is something like this. I know it's quite complicated, but let me go down to the very basics. If you are familiar with cloud computing, you will recognize most of these elements and terms. Down at the bottom, the green side is a set of hardware components. So you have your sensors, your actuators, the control systems that you may want to see. And then there is clearly an abstract layer. Well, clearly meaning that at some point there must be an abstraction. Still, at a hardware level, you may end up with something that is an embedded system or a generic operating system that can be reconfigured in the usual cloud way. But this is, again, down at the edge or in a middle layer. When I talk about middle layer, let me give you the simplest example might be some of the micro towers you see around in some smart cities. And inside these micro towers, you have systems like Intel boxes, literally like something like your desktop computer, running virtualized software that can be changed from a control system directly in a matter of few minutes. And these control systems can organize parking, the road traffic, security cameras, all sorts of things. On top, on the blue side, you have the real, let's say, the real environment that is usually identified in a cloud environment. But in this case, it goes all over in this fog environment. The typical references of computation, storage, networking, and now we have added another element, which is all this idea of acceleration. Because if you think about AI, as you've seen in one of the slides before, or machine learning, accelerators are an essential component to execute even more number crunching here to achieve some of the AI objectives that we may have. And then again, security that goes from the virtualized environment on this dark blue down to the lowest level where you may have crypto processors that can be used. And clearly management is another important element. So here we have API that can coordinate all these elements. Now here we are talking about small systems that are of a small form factor, but also low power and the cost of a few dollars that can all work on this in this environment. If you have attended one of, for example, a dynamic presentations, we were showing a Raspberry Pi Zero, clearly not maybe valid for many industrial solutions, but just in terms of cost, we are talking about something that has a cost of $5, $6, and it can run a full environment, full Linux-based environment where you can virtualize applications and run there and configure whenever you need it. On top, you have clearly all the software backplane where you have node management and finally application support and services. And where are we in terms of data management and data collection and usage? Well, we have this colored side, and our applications can be connected and modified whenever needed. They can use this environment, so we would be either there on this or on this side. So, having described fog computing and having seen what we have in an environment with Pi servers, what is really driving interest, not just in IIoT, but perhaps in fog computing in this case? Well, you probably are all either Pi users, or maybe your company uses Pi, or maybe you provide a solution based on or connected or integrated with OSIsoft Pi servers. You may also know, because it's been mentioned actually Tuesday during the keynote, that OSIsoft has now announced, well, it's been around for a while, but now it's officially out as one of the key elements for IoT, and more specifically in this case for fog computing, which is the OSIsoft message format. Why is this important? It's important because with the OSIsoft message format, you have a common way to use the most standard interaction among the various levels that they can start from the devices and sensors, and they can go up to Pi, or they can also interact with other components. So that is the step number one. What we have provided as a company, as Dynamic, is something that came straight from one of Pat Kennedy's idea of solving the problem of the green field, the new green field with all these new standards and new IoT solutions that should be in some way connected to Pi servers. So I mentioned before FogLAMP. Let me give you just a quick overview of what it is. We refer to FogLAMP as a platform for the Internet of Things and a component for fog computing. So if we go back for a moment to the slides related to fog computing and the Open Fog Consortium reference architecture, well, basically we implement the Open Fog reference architecture for Pi users. So you already have your brown field with the Pi server, and you may have all your green field implemented in a fog way using FogLAMP for your Pi users. We are not FogLAMP, by the way, is a software component. The name comes from, of course, fog on one side, the fog computing. LAMP is clearly some light, but also the concept of Linux, Apache, MySQL, and Perl PHP, Python. LAMP is the stack that has completely revolutionized or modified the World Wide Web. Everything nowadays in the web, on the internet, works pretty much, or 90% works with the LAMP stack. And we believe that we must have something similar for IoT. We are the main developers of FogLAMP, but we love to call us the captains of FogLAMP. As in every open source software, there is a captain, somebody who can help in coordinating all the contributions of this software. But in reality, the final result is a combination of contributions from everybody. And we're not just talking about software development and coders and developers. I'm talking about feedback, all sorts of comments of some features that are missing or some features that might be absolutely important, absolutely interesting. And so this is really what makes an open source software really successful. The target for FogLAMP is smart sensors, smart devices, embedded systems, data network appliances. We start from the very bottom where things can be connected together, and then we go up to Pi, where, of course, Pi can be your system that collects all the timed data, and you can be analyzed. We run on all sorts of different hardware components, as I mentioned. You can see down there from the smallest, like Embed OS, so we are talking about the ARM boards and chipsets. ARM is one of the main founder of the OpenFog consortium, down to the Raspberry Pis, or the tiny thing on this one here, sorry, I'm moving, is a tiny experiment that we created. We soldered together a small board, which is called the ESP8266, just a Wi-Fi board with a little bit of RAM in there, with a humidity and temperature sensor. A simple example of how you can plug in some software in there that can collect the data and perhaps analyze it in that small, low power consumption system, and then it can send some of the data up north. So from south to north, we can send this data. So here you see, for example, some of the plugins that we have identified and we have provided. But we are not the only developers, as I said. Anybody can contribute and add more like proprietary or non-proprietary plugins. And this is, again, the concept of the fog computing I mentioned before. And then we run on different hardware boxes, or for example, either Cisco or, well, this is BTE or Arrow boxes. I mean, there are many. And the idea is, again, in the concept of fog computing, you have resources like your hardware, like a smart gateway, and you can add extra features, extra components, software components that can be executed in there. And then we go clearly up to north, where we have historians, but we can also have big enterprise, big data, other cloud services, you name it. I was talking about the consumption of the data wherever it really makes sense to use it, and this is really the consumption that we can have east-west, wherever FogLAMP is installed. So something that can be used also at a very, very low level. So just to complete the picture here, I showed you this slide before. It's still there, and it's still like, okay, what can we do for this? I mean, how can we help the man right there at the center of this very complicated environment? The whole idea is, with FogLAMP, which is, again, open source and free to use. So we are not talking about something that must be purchased and it has a price tag, but it is something that can be used to connect all these things together. The idea is to have a unified view, because whatever you want and you need to take from the greenfield will go up there to the Pi system. Whether the Pi system is an edge data store or is a enterprise Pi systems up top, at the very, very top. And clearly, you still want to have your IoT solutions that are provided by other vendors. We don't want to take them away, not at all. But you want to have both opportunities and possibilities to see these things. So, the title of the talk is related to the plant floor. How can we see this in a plant floor? What can we do? So in this picture, just in a kind of a fairly modeled way, we identify the factory plant, where you see, of course, what it can be sorry, I'm moving again. I'm not sure for the recording, but okay, you can see here that we have where all the different systems running at the factory plant, so on the plant floor here. Now, the two important elements, or three, I would say, are, first of all, the data plane, because we care mostly about data from our perspective. And again, I talked about the concept of data in motion and data at rest. And the data in use is a combination of the two. And the control plane, that is, again, important in this area. But we refer mostly to this side with FogLAMP and clearly with the integration with Pi servers. And then the management plane that is somewhat very much related to the control plane up here. Now, the green boxes here are the ones that can be more, let's say, easily integrated in a fog environment, where your equipment and even legacy machines, etc., may be integrated with fog-ready solutions. How can we do that? It's exactly as I mentioned before. If you have an integration between FogLAMP and the Pi systems and the connectors interfaces, you can basically combine the two elements. So we would fit in this part on the plant floor, and in your data plane, we certainly help in the first part where we start from the machine, collecting the data or analyzing what's going on, moving up to maybe intermediate nodes, what we call the fog nodes. So the data is in motion, up to maybe some more complex and sophisticated storage nodes, where we may, let's say, find for the first time in this flow a Pi server, and up to maybe the analyze area where we have certainly a Pi node over there. And if you refer to maybe the headquarters or maybe third parties, as we were seeing in the previous slide, everything that you can see on the right, we may have either a Pi server or other cloud system there. And again, what can FogLAMP do? It can redirect in parallel data from the plant floor up to the HQ, to the headquarters, or to third-party systems. If you are more, let's say, familiar with the ISO 95 description of the different layers, and so we see here the process, the control, and the supervision, etc. Now, in fog computing, just to simplify the whole complex picture here, you have the factory boundary here. You simply replicate this at various levels. So the fog, in this case, is just a replication of the same components in multiple layers. And again, how can we integrate this with FogLAMP or Pi? FogLAMP would basically be installed, and it would control systems at process level, at direct control level. We are not talking about control in terms of controlling the systems, but we are talking about collecting information from the control systems. And that would be here, and then down in fog, and up to the middle layers and to the headquarters. So the FogLAMP community today is basically backed by, not just by us as captains, as we said, but by this name. So we have a quite significant number of participants already who are contributed to the system and the software. And as part of the Open Fog Consortium, we really, really hope that many will join us. There are other open source initiatives out there. I would say they're all absolutely great. Maybe some of you may know some of the Cura projects or the EJEX projects. They are very, very much related to the control aspect. We are very, very much related to the data aspect of the fog environment. So if you are interested, clearly, or if you as an end user or as a provider of, a technology provider are interested, please, you can come and visit us. Actually, the booth, I think, is closing soon, but I'm here. My colleagues, Bill Hunt is here, right in the back, right there. We are happy to, of course, take any question after this presentation. And you can always reach us. I mean, we are easily we can easily found with our first name at dynamic.com, just in case. If you are curious to see what we have and you are maybe a little bit more techy and you like to see what we really have done, well, we are on GitHub. So you can simply go to GitHub easily. You can search for FogLAMP, or you can remember that URL, which is not difficult. It's github.com/FogLAMP. And then we have FogLAMP with all the lamp uppercase and the F for fog. Or we have discussion groups. We are also clearly on Pi Square and in the Pi Developers Club, where we are happy to answer questions and provide more information for the Pi users. I think we have a few more minutes for some questions, if of course there are questions. Oh yeah. You may need a microphone. Yep.
Yeah. So there are edge devices and there are fog lamp comes in picture now, fog network. So how do you trade off between edge devices, and so how can you decide that we should put edge device here and then we should put fog network here?
On these devices, you're talking about how we could put fog lamp on these devices.
No. So there are either or situation you have to decide. Either you should put edge devices or you should put fog network.
Okay.
There are sensors available. Then how you should decide that you should put fog lamp, you should use fog lamp or you should use edge Pi?
Okay. Well, between fog, you're talking about between fog lamp and I mean, it could be anything else. Well, as I was saying, the main objective is related to what we want to achieve in terms of what is our need. Is it the control system? Is it the management system? Is it the data collection and data management? I think that is the main differentiator today. We are very much focused on data, and that is the key part. So if you are literally controlling the system, then probably you should look at some of these other open source solutions, and they are absolutely complementary. We can work together, and actually that is exactly the beauty of the fog computing. And we are, by the way, most of us are part of the Open Fog Consortium. So if we all do our job right, we will also be able to interact and connect together. Now, to your specific question, what should we use? That depends clearly on the system that you have. If you have a sensor, and this sensor is collecting data, I would say probably FogLAMP is the right component for you. If this sensor is very much connected to a PLC, there is an actuator, and you need to move something, or I don't know, control a pump or a valve or something, then in that case, you may want to use something else and have FogLAMP talking to this something else. I'm not sure it makes sense. I hope I gave you an answer.
Yeah.
Okay.
Hi, Ray Verhoff, OSIsoft. I like the terminology of southbound and northbound. Could you elaborate on exactly how you configure the workflow from one to the other? Like when readings come in through the southbound side, exactly how do you direct it to the northbound side? And if you wanted to install, say, analytics in that layer, how would you do that?
Okay, and that's a great question, because I would say the real answer would be, well, data should go everywhere, and we should really be able to consume it everywhere. So if we refer to well, first of all, it should be bidirectional. We should have definitely data collected at the bottom here from the south going up north. But for example, for I don't know, mentioning predictive maintenance, we might want to have some information that comes from the top down to the bottom, because at that point we might want to have like an analysis that identifies what are the differences between the current device running versus other devices that are in similar conditions. So we need to basically send data down south again. Now, when do we send data down? When do we send it up? That really depends, again, on how this data must be consumed. If we have applications that must analyze this information down here, I would say, well, the data should reside in there, and we should move this data down to the bottom. If we have information that must be all aggregated all together, and then we need analysis at a higher level with all this large number of let's say, of data collected, then it should be up at the top. So we should be able to send the data at the top. Now, just to finish on my answer, the point is we have historians up here that can take the data and they can then provide this information once they have been analyzed down to various levels whenever they are needed in a more, let's say, in an analyzed version. So we take raw data from the bottom, we bring it up north, and then we crunch this data, we analyze it, and then we send it back. That would be an example of how this can be executed.
The question, I agree with everything you said. The question is exactly how do you configure that?
How do I configure that?
For instance, you have MQTT on the southbound side.
Yep.
And you have OMF on the northbound side. Let's say, for the sake of argument, you wanted to accept a packet on MQTT. You wanted to translate it to OMF.
Perfect.
Somewhere you need to configure the endpoint of OCS where you're going to write it, and then you want to invoke this workflow and get it to move.
Okay.
So how do you do all those steps?
Okay, I now I understand the question. Sorry, maybe I gave you maybe another, a different answer. But yes, so by default, with FogLAMP, we have everything goes from south to north, and that is the unidirectional version that we have today. By the way, we are still working. I mean, it's still a very, very fresh, young project, but it goes from south to north, and everything goes up to the gap north. So if you think that to have, like, I don't know, let's say 100 sensors down here, all this data will be collected. It will be tagged at the edge, tagged in a way where you can identify where this data comes from, and it will be sent up north. So there is no filtering. Everything goes up. And then at pi level, this data will be, and through, of course, that will happen through OMF, through the OSIsoft message format, where we have the definition of the metadata and the real data combined together. So we have pi data and AF and the asset framework that is fed in this way. Okay? Now, you may want, in some cases, to filter it. This is not what happens by default, but you may want to have a filter where some data doesn't really need to go up because it must be consumed only at this level. I can't say it must be like this now. I mean, it depends, really depends on the implementations. But the default version is everything goes up, and then somebody will figure out what to do with this data.
So still agree, how do you configure that?
It's in FogLAMP, in a specific environment where we...
Is it like a configuration file where I say I want to receive MQTT data and send it to a specific endpoint?
No, it's not MQTT data. It depends on the tag that where we identify all the components here. So everything is tagged in a way that then the configuration may define a specific filter. Yes, you have a clearly. Sorry, this talk is about fog computing in general. We had, for example, this morning a talk where we specifically described how this can be done, etc. But to answer your question, yes, there is a management console where you can define a filter. Just to go into the details, we have what we call a JQ filter. All the data in FogLAMP is JSON-based, so you filter it through queries that may identify some tags versus others. And so you may say, I don't want to have all this data, I want to have only a subset of that.
Okay, got it.
I think he's asking message exchange. You have one protocol coming in this certain protocol, and you want to convert it to another protocol, OMF.
Yeah.
Okay.
How does that done?
It's done inside FogLAMP by plugins. So in this case, it's done inside the FogLAMP infrastructure, being a platform with multiple plugins. It doesn't matter which protocol you are using. The plugin, provided that you have a plugin that can understand that protocol, whether it's MQTT, HTTPS, CoAP, etc. Once you tag the data doesn't have any protocol related to that. It's just data. And so the protocol that you have on the south side can be completely different from the protocol that you have on the north side. And it can be OMF to go to a Pi server, OCS, etc. Yes. And then, of course, we can go down to all the layers. It can be through, I don't know, LTE or just a direct connectivity on the Ethernet, etc.
Ladies and gentlemen, I'm sorry, but the time is up, and we have to prepare the room for the next talk.
Thank you.
So thank you for your questions. You can find me